All right, guys, today we're going to talk about classifying numbers. So we have three different classifications for numbers, and they are rational, integer, and whole, or RIW. Okay, so that is our abbreviation for classifying numbers. And normally you're going to see a circle that looks like this. So we have whole in the center, we have integer, and then rational is our outside piece, okay? So RIW. All right, so let's talk about how to classify numbers. So each of our topics has a different characteristic that helps us to classify. So our first one is going to be rational numbers. And in order to be a rational number, it must have a fraction or decimal part. Okay, so if it has a fraction or decimal part, that is going to make it a rational number. So examples might be negative 2.3, or you might say 10 and 3/4. Okay, so you can see that both of these qualify as rational numbers simply because they have a decimal or fractional part, an extra piece on top of the whole number. Okay, so fractions and decimal parts all belong in rational numbers. So they will belong in this outside section of our circle. Okay, all right, our next topic is going to be integers. And so in order to be an integer, we will have a negative. So not only are they negative, but they have no fraction or decimal part. So they have to be negative counting numbers. So -1, -2, -3, -478. So again, no fractions or decimals in this section because all the fractions and decimals live in rational. So these are negatives, but they are negative counting numbers, -1, -2, -3, numbers that you can count on your fingers. All right, so examples of that might be -15, or we might say -478. Okay, again, negatives, and they have no fraction or decimal part. Whereas up here, even though this was negative, it has a decimal, and decimals have to live in the rational section, okay? And then our third section is going to be whole numbers, and whole numbers are the positive counting numbers. So +1, +2, +3, +4, so on and so on. And those positive counting numbers, we might have positive, 8, or you might even see it like this. Let's do 18/3. And so you guys are like, wait, Miss Turner, that looks like a fraction. So even though it looks like a fraction, we would divide it, and we know 18 divided by 3 is actually equivalent to just 6, and therefore that makes it a whole number. So just because it looks like a fraction does not make it a fraction. It actually has to have an extra part. So this is a whole number with an extra part. This is a whole number with a decimal. So those are all going to be some sort of extra piece, whereas this one doesn't have any extra pieces. This is 6 wholes when I divide it, okay? So let's practice that a little bit more here. It says label the following diagram with the labels rational, integer, and whole. So we said rational is our outside section, and remember what goes here are going to be our fractions or our decimals. All right, so I'm going to look at my list up here at the top, and I'm going to grab anything that's a fraction or a decimal. So I'm looking, and I'm like, no, that's not a fraction or a decimal. No, that's not a fraction or a decimal. Oh, ding, ding, ding. There's my first one. So I'm going to grab 3/4. I'm going to label it with an R for rational, and I'm going to put it in my rational circle because I know if I divided, I would get 0.75, which is in fact a little decimal part, and that belongs in rational. All right, I'm still looking, still going through and looking. So does this have a decimal? Absolutely. So I'm going to label it with an R, and I'm going to write it down here in the rational section. So 16.2, and that's a negative. It's totally okay that it's a negative because it has a decimal part, and decimals must be in the rational section. I'm still looking, and I'm like, ooh, this looks like a fraction, and so I know I need to divide it. So 10 divided by 2, well, in this case, 10 divided by 2 is equivalent to 5. And so 5 is, in fact, not a fraction or a decimal, and so I'm going to skip that because it doesn't go on my rational section. And then my last one is a 0.3511, and that is clearly a decimal, a very long decimal as well. And so it is going to belong, I'm going to label it with an R for rational, and I'm going to put it in my rational number circle. So again, everything that lives out here has a fraction or decimal part. All right, let's go to the second circle, which is going to be my integers. And remember, these are going to be my negative counting numbers. All right, so I'm going to go through and ask myself, is it a negative counting number? So I'm looking and I'm like, let's see. Ooh, that's a negative counting number. So I'm going to grab it and I'm going to write it in here and label it with an I for integer. And I'm going to keep going. Is 0 negative counting number? No. We've already eliminated this one and this one. Is 5 a negative counting number? No. Is this one? No, we already eliminated it because it's a decimal. So the only one that counts as an integer would be -8. And then our very center is going to be our whole numbers. And again, those are positive counting numbers. Positive counting numbers. So all I'm going to do is I'm going to go through and grab anything that's a positive counting number. So we have 0. So 0 is going to go here in my whole numbers. And then I have, let's see. Oh, I need to label it. So this is a whole, so I'm going to label with a W. And then I keep going down. I already used that one. I already used that one. Here we go. So remember how we divided 10 divided by 2, and we got 5? Well, 5 is a positive counting number. So I'm going to label it with a W, and I'm going to write the original 10 over 2. And then I'm just going to go ahead and write equals 5, just to remind myself that's why that fraction is there, because it's technically a whole number. All right. So let's look through our first example. So it says, which of the following represents whole numbers? And it says to choose 2. So remember, just to remind myself, whole numbers are positive counting numbers, okay? Positive counting numbers. So I'm just going to go through, and first thing I'm going to do is I'm going to eliminate anything that's negative. So I'm going to go through and I'm going to mark out, oh, that's a negative, that's a negative, that's a negative, and that's a negative. And again, I eliminated those because anything that's negative can't be a whole number because whole numbers are positive, okay? All right, and then the second thing I'm going to eliminate is I'm going to eliminate anything that has a fraction or decimal part. So I'm going to go through and say, let's see, this one has a fractional 2/3. I'm going to leave this one because I'm not sure. Like this, I need to divide. Over here, I can see 0.35 is a decimal. That's an elimination. This one, again, I can't eliminate without dividing. I'm not sure. But I can see this is clearly a decimal, so I'm going to mark that out. And this is clearly a decimal, so I'm going to mark that out. So I have a couple that I need to test, and I'm going to look at those. So it does look like there's more than 2 answers, but we're going to see. All right, so I'm going to go through, and I can clearly see this is a positive counting number. It is +9. I could definitely count to +9 on my fingers. So that's a definite correct answer. All right, and then you have 3 over 3. Well, what is 3 divided by 3? Well, that's just going to be 1 whole. And 1 whole is definitely a positive counting number. So that's a good answer. All right, and then we have 0, and I guess the 0 was supposed to be by itself. It might have been supposed to be on the back of the decimal, I'm not sure. But 0 is in fact a whole number, so I'm going to circle that one. So there's definitely 3 answers and not just 2. And then this last one, 15 divided by 8, and 15 divided by 8 is going to be about, let's see, it's going to go in 1 time, and there's going to be 7/8 left over, or as a decimal, that would be 1.875, okay? So we can clearly see that this has a fraction or decimal part, and therefore it belongs in our rational section, so I'm going to eliminate that one. So the only ones that are whole numbers are going to be my +9, my 3/3, which equals 1, and my 0, all right? And so instead of 2, there's actually 3 correct answers. All right, let's look at examples 2 and 3. So occasionally, they are going to ask us to identify the set or sets in which a number belongs. So when you think about that, you need to think about your rational number circle like this. So remember, I drew it at the top. We had our whole numbers in the center, and then we have our integers, and then we have our rational. Well, what you notice is that everything is inside rational. Like if I were to color in the rational circle completely, it would cover up integers and whole numbers. So everything is inside this circle. So technically, everything qualifies as a rational number that we talk about, okay? And if I were to color in just the integer circle, everything inside that circle would be considered an integer, including those whole numbers, all right? And then, of course, we have our whole numbers, which are in the very center, and if I color them in, they are there, okay? So you can see that there's kind of a inside circle here. It's kind of like you have toppings on your pizza, and then you have cheese on your pizza, and then the rational is the crust. So if you think about it, everything's on top of the pizza. It just matters on what part of the pizza it's on, okay? So let's look at that with this strategy here. So when it says sets or sets, when it says this, that means we're probably going to have more than one answer. And so your first job is to decide, where does it best belong? Like, where is it going to go? Kind of like what we identified up here is, where is it best going to go? Is it going to go over here with decimals? Is it going to go in here with integers, negatives, or is it going to go in here with my positives? And so that's our first decision. So where is -2 going to belong? And -2 is a negative counting number, so it is going to belong in our integers, okay? But remember, the integer circle here, it's inside the rational circle. So if I were to trace outward, those are inside of each other. So what I do is I just trace backwards. So integers live inside rational, and therefore my answer here is both integer and rational. That is my final answer for this question, is because all of these integers are also inside of this rational circle, okay? All right, so let's try example number 3. So example number 3, again, says which set or sets, so I need to be prepared to have multiple answers. But my first job is always to just put it where it belongs. So where does 0.35 belong, or where does 35 hundredths belong? And so 35 hundredths is a decimal, and we know decimals live in our rational circle. So it lives here. If I trace backwards, is there anything outside of that circle? And the answer is no. Okay, so again, when you trace backwards, you're looking for, is there anything outside of that circle? And the answer, again here, there's nothing in front of the R. Therefore, R is the only answer for this one. So my final answer is rational only. So when it says set or sets like this, you are going to use this strategy where you take your RIW and you just trace backwards. You just trace it backwards to see what lives outside of that circle. All right, and that is classifying rational numbers. Remember, rational numbers are fractions and decimals. Integers are negative counting numbers, and whole numbers are positive counting numbers, including 0. And that is classifying. Guys, go practice.